tutorial on DeckGL and Observable. We'll be using Observable as the platform that we build DeckGL maps on top of. What's DeckGL? DeckGL is a Uber project that was open sourced. Allows people to do visualizations on maps very quickly. So pretty mature, pretty fun to use, pretty easy to use. If you know just a little bit of JavaScript, and if you don't know JavaScript, that's okay. You don't have to know much, just a little bit. After this tutorial, you know, if you're not a programmer, you can, you know, do things and just like twiddle specific variables, and you'll see things change. So kind of a nice thing about Observable. So you'll be able to see that, and yeah, hopefully we'll have some fun. This is brought to you by Hackforge, which is a Windsor group, Windsor, Ontario. It lets people, you know, join events, local events on technical topics. If you like what Hackforge is doing, you can buy a membership, like some voting rights and a couple other perks. But the main reason you do that is if you want to support the organization, put on more talks. It's not compulsory though. The memberships are not required for attendance. And if you want to know what's going on, just sign up for the newsletter, and you'll get a monthly newsletter on all the events that are occurring. All right, so that's Hackforge. This you'll have noticed that a little bit in the descriptions that this is also put on by me, Median, and Moose. This is a podcast that me and 3 other people in Windsor put on. So if you like this stuff, maps and visualization of open data, you can subscribe to the podcast or the blog here, and get, you know, monthly content like this. All right. So that is that. Without further ado, let's get to the point of this. So this is all about DeckGL. So as I said, we're going to use Observable to look at DeckGL. Observable is a execution environment for Java. Lets you run, well, JavaScript lets you run JavaScript scripts and see the data real time, like so, you know, most easily, like 2 + 2, right? It's 4. It's the kind of thing you can see. Kind of this is all in notebooks. So if you're familiar with like Jupyter notebooks or something like that, it allows you to see content and code in one environment. So if you want to know how someone built, if someone sends you an article that's in Observable, you want to know how they got the visualization that they're showing you, or how they, you know, did all the mechanics of it, then you can do that by clicking on a cell and seeing it. So the first thing we're going to do is import something that's not DeckGL related, something called Mapbox. So Mapbox is like a tiling layer that and it has its own actual like programming environment as well, and a whole bunch of other libraries. But Mapbox maps you might see online a lot, that kind of thing. It's a competitor to Google Maps. But this is the tiling layer that DeckGL uses by default. A lot of the examples you'll see here are around that. Now you can actually use Google Maps as the tiling layer if you like as well. But that's not as common, and I don't think, so you won't see as many examples of it. So over here is, now we also need to import DeckGL. That's what this is. We're going to import it at a very specific version, just in case something breaks, 841. All right. So all this does is goes and gets the DeckGL library from NPM. All right. So that's just some stuff you can copy and paste and put into every notebook you develop. You don't have to change these very often, unless maybe you want to change the versions of Mapbox or the versions of DeckGL that you use. Okay, so now we're going to create a function. So a function is just a piece of code that allows you to provide inputs. So we're going to provide an input of layers and pitch, and then get an output. The output we're going to get here is a map. So over here we say, okay, so if they didn't provide a pitch, give it 0. Over here we're going to say, okay, so if it's create an HTML block. This isn't, so this is JavaScript, but you wouldn't see this in regular JavaScript code. This is something observable specific. So we create an observable HTML block that we can use. Another way to how you do this outside of observable is just define this in your HTML page, and then reference the container via an ID. Here we just get the container and we reference it directly inside DeckGL. So that this is where our map's gonna go. It's a little HTML block. Then we create a new DeckGL object. We pass it the container. This is the same as saying, container is container. We pass it a container. We pass it a map tiling layer. That was Mapbox back here. We give it some access tokens. So 1 second here, I have to go get my token. We give it an access token. I'll add that layer, show you the layer that'll happen. Give it a style, give it a Mapbox style. This is going to be, we're going to create dark maps. But if you go and just Google Mapbox styles, Mapbox dark version 10, you'll actually see all the other styles. So there's a light style and other things as well. We're going to give it some layers that the user will pass. So layers is where we're going to spend most of the rest of the time in this tutorial. Give it a view state. So over here is a latitude and longitude of where Windsor, Ontario is. I'm going to show you the data we're going to use soon. We'll give it a zoom, give it a pitch, right, which by default is 0. That means that the map isn't rotated by default. And then we're going to return the HTML container. So that's all get DeckGL map does. Just sets up the map. Now this is going to fail if I save it. Right? You see there's a runtime error, token is not defined. So I actually have to give it a token. So that's what I'm going to do here. So don't use this token. This is my token from Mapbox. I change these frequently. So if you use this token, your maps will break. Also, get your own Mapbox. Mapbox is for sort of like work that we're doing is free. You get a certain amount of what are called API calls free. This is so you're limited by that. If you use my token, then you're using the same API token calls I'm using, which means if everybody does that, then eventually it'll run out, and then I'll have more incentive to rotate my tokens. But this is just your token. So go set up a Mapbox account at mapbox.com. You'll get your own. You don't have to provide any credit card information or anything, and you'll get your own token, and then you can build maps with them. All right, so that's my token, and my error went away. Right, so now I have a function. That's what this F is. Kind of looks like in math, right? F, I give it layers and pitch. All right, so that doesn't look like anything yet. So let's actually go look at what that map is by running the function. That's over here. We're going to run the function called DeckGL, get DeckGL map, and we're going to pass it no layers, just to show you what the map looks like originally. That's what the map looks like. So at longitude 82,935, and that longitude and this latitude 42,2767. That's what the map looks like. At zoom 11.5, and you can zoom as well, right? So if you guys don't know where if there are any non-Windsorites on the call, if you don't know where Windsor is, it's actually just across the river from Detroit, right? And you can keep zooming out, zooming in, scrolling. So DeckGL maps are kind of nice too. Let you zoom in, zoom out, scroll just like Google Maps. But one thing, it also lets you rotate. Well, change your, what I'm doing here is I'm holding control. This changes your pitch. We're going to create a 3D map later and give it a pitch. But if you ever do any 3D map visualizations, that's going to be important. Okay, so that's how that works. Before we get to our first layer and the data, any questions so far? Okay. So City of Windsor. So what we're going to map today is snowplows. So the City of Windsor has winter control. They publish to their website all the tracks, the X and Y, the lat and long coordinates for the snowplows on a regular basis. You can also go and look at it. They got their own visualization here. If the data was new, this is pretty rudimentary. If the data was recent, if there was recent snowfall in Windsor, then less than 4 hours, it would show you a heat map. So I'm going to show you how to do a heat map. But what we're going to do is we're going to look at snowplow. We're going to visualize the snowplows in Windsor based on some historical data. So good. So this is the data we're going to visualize. I need the data to put the data inside Observable though. So to put the data inside Observable, I'm going to go to File Attachments and click Upload. So in here, I'm uploading some snowplow data. This is the data set for 0215 to 0221. Okay, so it's 9 megabytes of snowplow data. I'll show you what the data looks like right now. So we're going to, I'm going to do this thing called copy code, which is kind of useful. Copies a snippet, code snippet to your clipboard. And then I'm going to show you what that looks like. Okay, this is the file attachment object. If you wanted to, that's just the file attachment. So if you wanted to see the raw text, you could go .text here. But I know it's a CSV file, so I'm going to say it's a CSV file. All right, now I have an array of objects. The array is 141,000 large. So it's 141,000 rows in my CSV file. You can see it has latitude and longitude here. Some stuff around whether the plow was engaged or whether the spreader was engaged, whether the snowplow was on, right? It gives you a truck number and gives you a date. So that's all that. We can also do a little bit more here and go typed true. So now what it's done is it makes a guess. It says, okay, so these things used to be strings. Now they're numbers. And so I can operate on those numbers, effectively just telling Observable to try a little bit harder in parsing. All right. That is the data we're going to operate on, but it's not we haven't given it a variable yet. So I'm just going to call that data. So now I have an array of 141,000 elements, 141,000 objects. It is called data. Okay, that's how that works. Next thing, let's try map that. So we have, right? We have latitude and longitude here. So let's just try and take all the latitudes and longitudes, 141,000 of them, and put them on the map as dots as a first step, just to see what that looks like. So I'm going to call my DeckGL map again. But this time, instead of passing it, last time we did this, right, to get an empty map, we passed it an empty array. So there were no layers. Now we're going to pass it one layer. It's going to be a scatter plot layer. If you're interested what layers are available, if you go to the DeckGL documentation, here they all are. If you do some mapping in other contexts, you might be used to GeoJSON. So you might want to just have a GeoJSON layer instead. You can click on them and they'll give you a nice example up here of what it looks like and a nice example of, you know, how they built it. So we're going to do scatterplot layer, which is down here. So dots on a map, right? So we're going to put dots on a map here. So get the scatterplot layer. We're going to say, give it an ID. It just has to be unique for the maps in your web page. Data is just going to be data. That's the thing I labeled over here, right? So we're going to give it an array of JavaScript objects. That's what it likes to consume by default. Pickable is true. That means you can, if we're not going to do it, but if you have a tool, if you want to do tooltips inside, that's what a flag you can turn on. Opacity is 1. That means these are going to be dots that you can't see through. They are going to be filled dots. They're going to be have a radius of 1 meter, but never be smaller than 1 pixel. Also never be larger than 1 pixel. So it's just basically just 1 dot. And then give it this get position is the important part. So we say get position, we give it a lambda. So lambda is just another function. Remember we defined that function before. But we're going to map D. It's going to take a D that's for every row inside our array. We're going to say d.latitude over here and d.longitude first, and then d.latitude. This creates a little coordinate. We're going to say give it a radius of 1. If you wanted to have different size circles, right? Maybe you had something else in another element in here that you wanted certain circles to be bigger if you're doing a different kind of map use case, then you would put in d dot whatever that value is, right, for that. So that's what the get radius is. And then we're going to make them similarly. If you wanted to change colors for every dot, you can provide a different kind of color range here, but we're just going to make every dot orange. So let's see what that looks like. So that's good. All right, so here's our scatterplot layer with 1 dot for every element inside the CSV file. Good. There you go. All right, so we're going to look at more complicated layers next. Is there any questions before we continue? Okay.
Yeah, sorry. Quick question. That file attachment function, was that observable specific?
Yes. So this is observable helping us. If you were using something inside a regular web page, you might have to do like maybe a fetch for the CSV file from somewhere else, and then maybe use D3 to parse the CSV file or a different library. And so that's a little that part of getting the data inside the notebook is observable specific. It's a good question.
Got it.
Good. The rest of this is less so. Although if you're gonna put DeckGL somewhere else, The easiest way to do it is actually probably inside React, because there's really good React bindings for DeckGL. And then DeckGL just becomes a component, and all of this and the layers inside DeckGL, or the DeckGL map, just become children of that component. And then it's really easy. These just become props. Sorry to anyone who doesn't know about React, but that's how easy it becomes. Good. So now there's a problem with this map, right? So it's very difficult if you just put all the dots on the map, right? It's very difficult to understand what the density of the dots are. You can get some kind of zoom in and out and get some kind of feeling about how often a plow goes on a road or goes into an area, but it doesn't give you an idea about how often it happens. What we need to do is aggregate these dots somehow. One way you can aggregate dots in this particular use case is a heat map, and I mentioned this is the default one that the city of Windsor puts on their website. So if you want to replicate theirs, this is how you could do it. So what we're going to do is you're going to go and create a heat map layer. That's over here. So they got one there, right? So they do a whole bunch of stuff in San Francisco, right? And a lot of mapping for their examples, but we're doing Windsor. So here's a heat map layer. Give it another ID. Give it the data. We're going to do the same mapping for position. So we're going to say for every position, d.longitude, d.latitude. That stuff's all the same from the previous layer. Aggregation is sum, which might seem kind of weird, but the default value in all of these is 1. And so it's just summing 1 for every dot, effectively doing a count. But there's no value here for count. You can override this if you had a different value. If each of your dots had a different weight, you can put in that. It's over here. Yeah, get weight, right? The default's 1. I don't specify it, but you could if you had, if your dots were special. Our dots aren't special. We just want them on the map. Radius pixels is 10. So you're going to see how that becomes important. And then color domain, I'll explain a little bit about that coming up. So what the heat map looks like. And so it takes this radius, right? And you can see it's in pixels, which means if you zoom in, your pixels change, right? So 10 pixels becomes a smaller area if you zoom in. And so, yeah, watch out for that. So radius pixels is 10, right? So if it counts the number of dots inside the area, and then assigns, if there's more dots, you're redder, and if there's less dots, then you're yellow or non-existent. So this color domain, what this is about is if we remove this, I'll show you what it looks like. So if we remove the color domain, the data is such that the places where the plows start drowns everything else out, right? So the plows start here and here in Windsor. And so they're a lot. And so there's a whole bunch of plow activity right there, something like they park, right? And so if that becomes the red, and then everything else becomes really faded. What I do here is I say, okay, so if you only show something if there's 100 dots in your radius, and go up to 1,000. So if there's you're as red as your red can be if you have 1,000 dots in your radius. And so, whoops, that's what happens when you remove the comma there. Okay. So now that's what I'm adjusting the color domain here to sort of give it a cutoff point to make the map more interesting. It's a little bit misleading because so the plows are spending most of their time here, but it's also very uninteresting knowing where the plows are parked, right? So there you go. All right, so that is heat maps. Next thing is if you don't like heat maps, and you might not like heat maps for other certain use cases, for roads where you have like lines here, heat maps actually make a lot of sense. But sometimes you don't have roads or something like that. And so an alternative I just wanted to show you here is hexagons. And so hexagons here, we're giving now we divide the map into hexes, into hexagons, and we give them a radius of 50 meters. And then we can also give them a height here, which is kind of useful. If I give them the same, this is the same position, but the height is going to be the same as the color. That's over here, except 150 now instead of 1,000. There you go. I just wanted to show you the hexagon layer here to show you that 3D maps are possible with DeckGL. So same kind of thing. A redder hex means plows are there more often, but also a taller hex means the same thing. But if you have 2 dimensions of data, this is a good way to map it. 2 dimensions of dot data, like so, where you like not a chloropleth thing. You can also do chloropleth maps. That's where you just divide the maps into polygons, and then assign a color and height to them. That's also possible. But if you don't have that, they're sort of scattered all over the place and they're just points. Hexes are a good option. Okay. All right. So the next thing is, okay, so this is where we get a little complicated. I'm going to take a quick break. Any questions before I get into a little more coding stuff?
Yeah, small question. In your heat map, you have, what is it, radius pixels, I think it was?
Yes.
Could you specify just radius in meters? It just seems odd to me that the map would change when you zoom in and out.
Yeah. Let's see. So it could just be the nature of their implementation for heat maps. Yeah, it doesn't look like it. So, and there's some things, right? So you can also divide the map into other like into columns and hexes, like I mentioned, the hexes. So and then it would be static, right? So you can see that the hexes here are actually not specified, but the radius here, if you look at the hex map, the hex layer, hexagon layer documentation, it says the radius here is in meters, and so instead of pixels. And so yeah, you can see if we zoom in here, the hexagons get bigger, right? It's not like the hexagons become smaller as you zoom in, like the heat map does. Mm-hmm. Yeah, so I think it's just a different trade-off. Yeah, so this is pixels for heat maps, but there are other layers inside DeckGL that allow you to specify meters, but it doesn't look like it's an option here, one or the other. It looks like you're stuck with pixels for a heat map. Okay. DeckGL. Okay, good question. And a definite downside. Yeah. Good. All right. So let's go. So the next thing is we're going to do a little more. So this is great, right? So we have an idea of where the snowplows went in terms of density inside in Windsor. But maybe you want to know what paths the snowplow took. You have a different kind of, you want to understand where the plows went in a slightly different way. And so what we're going to do here is create paths. To create a path, instead of having just a array, right? We have an array of objects. We're going to now smush the, and that's a technical term. We're going to take smush all the objects into trucks, right? So we're going to key on trucks and put all their positions inside their specific buckets. So we're going to have a bucket for like truck 9449, and then all the positions of truck 9449 will be in that bucket, all the positions and timestamps. So we're going to call that a path, right? So we are going to do it this way. Before I get there, I'll show you how to like smush all of them in their buckets. Maybe I'll do that first, since I just explained the buckets. All right, let's do this. So we want all the trucks in their specific buckets. Yeah, okay, let's do it. So that's over here. So reduced equals, so we're going to take data, and this is a little more advanced. We're going to reduce it. So reduce takes something called an accumulator and the data element. So we're going to, if you're familiar with map reduce, this is the second step in it. So reduce says, get me, aggregate the data according to some kind of algorithm. This is the algorithm. It says, okay, so if I don't have something inside my accumulator, if my answer doesn't have a truck bucket yet, it says, if I don't have a truck bucket, make a truck bucket. My truck bucket has a truck ID, a path, and some timestamps. My path is an array, so that's my list of coordinates. And it has a list of timestamps for those coordinates too. So if you don't have a bucket, make the bucket. And then for everything inside, for every element of data, put in the latitude, put the current longitude and latitude in the path for the truck in question, and same thing for timestamps. This time we're gonna actually get Unix time here. So that's the number of milliseconds since epoch, which is 1st of January 1970. But you don't have to worry about that. It's just a number that represents time. So if we look at what this looks like, we can see, oh, now we have a truck bucket, 1002. That's truck 1002. It has a path, right? This is the path my truck took. And these are the timestamps associated with each hop in the path. Yeah. So that is how that works. Then we have another bucket for truck 1111 and so forth. Right? Okay, and some of these buckets aren't as big as others because the truck wasn't as active, or maybe the truck's ID changed. I don't actually quite know how these IDs get assigned. So why this one's like 32, for instance, could be maybe the ID got switched. Maybe if you turn off the truck and turn it back on, it gets a new ID. Not sure. Anyway, that's how that works. So now we have a whole bunch of trucks, and we can potentially display these paths. If I display the paths, though, it's going to be hard to tell one truck from another truck. And so what I want to do is assign the trucks a color, right? So what we're going to create a color scale here to do that using D3. So D3 equals require. I think it's version 6 now. Yeah. Okay. So D3 is another visualization library. D3, you might know about it, but it also does maps. You can see that D3's libraries are now unobservable. That's because the inventor of D3, Mike Bostock, decided to start Observable. So they're very heavily linked at this point. So D3 is is a visualization library. We're just going to use a small part of D3 right now, which is its color scales. So we're going to create a sequential color scale and give it a minimum and maximum. We give the get color scale, we will provide the values. And then it's going to be rainbow. So if we look here, D3's documentation. So this is the interpolate rainbow color scale. So basically, it's all the colors of the rainbow, and we're going to assign the truck color to this rainbow based on the minimum and maximum truck numbers. Okay. So we're going to create this color scale here. Okay. So here. All right. So good. We need that. Trucks equals that. Okay, so reduced. Yep. Yeah, so we have the color scale. We're going to start at 0 and go up to the number of keys inside the truck buckets. So start at 0, go to the number of buckets, create a new array called trucks, and then for every truck ID, assign it a color using the color scale. That's what that does. So trucks. Okay, so that's what we have here. We have the same thing. We have our truck buckets, but now each truck has their own little color. The color is an array, red, green, and blue, up to 256. That's how Observable likes its colors. Good. Same thing here. This is this truck's color, which is very similar because they're close together in number. And this is this truck's color. Slightly different but also very similar because 1605 and 1610 are very close. So that's now my trucks each have a color. Okay. So I think, let's see, I think that should be good. Now we can build a path layer and look at all the trucks in the path. So here we have a DeckGL path layer. We're going to actually go trucks here. Let's go with something different. I'm going to say the data is trucks. And the good news is DeckGL for the path layer expects buckets, expects a bucket of coordinates. So you give it a path, you say d.path, right? And give it a color and d.color. So I knew this kind of cheating. I knew what this was ahead of time, and so that it kind of worked backwards. You see what DeckGL path layer requires, and then you go and you manipulate your data until you have the requirements. But that's how it looks. See, here are my track paths. So each truck is a color of the rainbow, and you get an idea, like this guy over here by the airport, where the hospital will be soon, is this orange guy, right? This is the path he took to do the snow routes on County Road 42 and Baseline and County Road 17 and 9 and 8. So that's how the path layer works. Kind of useful if you want to know what individual paths the trucks take. There's a missing dimension here though, and that is time. And so what we want to do is now take this map, which is very busy and difficult to read, and we want to add a time variable. You can see I already put the timestamps in, right? Our buckets, we have timestamps here. And so now we're going to scroll back and forth in time to see the paths the trucks took. Any questions before we do that? Okay, and this will be the last one. Okay, all right. So we're getting progressively more complicated, but don't worry, right? So this is a lot. Good news is I've written this all down. So I'm going to, after this talk, there's a tutorial on DeckGL I'll put on my Observable page, and you can go and see all the code and how everything was built in this. So don't worry, you'll have all the code to reference if you want to do something similar in your environment, or even just look at the simpler ones. If you just want to see, get refreshed on what those were like, then it's all available. Okay, so that's good. So now we're going to look at time. What we want to do is sort of create a over here. So there's something called the trips layer here. So you can see here, and it's not a very exciting example in here. Sometimes these aren't exciting, but you can see in a specific point in time, there was this shows you when like the darker the line, the newer the path for the vehicle in question. So I think it actually has a better example here of the trips layer. So here's taxis in New York, right? So you can see here, there's similar kind of thing, right? We have a lot of trucks, not as many, but we have got a lot of trucks, and they're taking different paths. And there's a time here, a time variable. So what we want to do is be able to move that time variable, and then the paths will highlight differently depending on the time. So let's go back to the trips layer. Okay, so the first thing we need before we build the trips layer is that indicator of time. So what we're going to do is find the minimum timestamp. So this is just using D3. So get the minimum on data, and how do you compute based on the time that the data is. So that's the minimum timestamp there. And I think I also have the maximum. So the maximum adjusted timestamp is here. So this is the minimum timestamp. This is the maximum adjusted timestamp. The adjusted timestamp is just the timestamps minus the minimum. Effectively, I'm giving myself a new epoch. So my zero timestamp is the first time inside my data set. This is useful for when I do the mapping. So I know 0 is time 0. And then if I go to 5,000, it's 5,000 milliseconds or 5 seconds past time 0. All right. I also have a max minutes here. So this gets me the number of minutes inside my data set. So I take the maximum timestamp in milliseconds divided by 1,000 to get seconds, divided by 60 to get minutes. So there's 2,809 minutes in my data set. And then I'm going to create an array of minutes. You'll see why I need one minute per, why I need an array like this coming up later. It's basically so I can build a scrubber, but I'll show you where that comes in. We're also going to create another function called pad. all pad does is takes a integer, and if it's less than 10, adds a leading 0. I'm going to do this so that my time when I display it, so that if it's 9, if it's 9 minutes past 5, it doesn't say 5 colon 9. It says 5 colon 09. It's just for viewing it. Right. Good. So actually, all of that is set up so I can build a scrubber. So I'm going to go here and import someone else's scrubber that they built. So let's go look at what a scrubber is. So you can see what a scrubber is here. It's like it's a slider, right? That you can move back and forth, and also autoplays if you click the play button, right? So that's what this is about. And that's why I need an array and that kind of thing. So I'm going to import this scrubber from someone else's notebook. Nice feature about Observable is you can import other people's work into your notebook, so you don't have to reinvent the wheel every time you do stuff. So we're going to create this scrubber called current minute. And so it looks like, so there's a delay here. So every 10th of a second, a minute will progress. You can see that. And then it starts at 0, 0 being the minimum, the minimum timestamp, right? And then it gives us the year, month, date, hours, and minutes. That's why I needed the pad, because I wanted to, I wanted to pad month, date, hours, and minutes, right? Because we always do the O over here. If I didn't do the padding, then this would say 843 instead of 0843. Anyway, this wouldn't say 02, it would say just 2, which kind of looks weird if you're looking at a date. So now I have a current minute. All right. That whole thing was to get to this point where I have this variable called current minute. View of is something special and observable that allows you to use values inside your HTML data to populate a variable. Okay. All right. So now we got a scrubber, and we're going to build our last map. We're going to build the last map, last layer. Okay. That's fine. Before we can do that, we're going to do this a little bit differently. So we're not going to call getGL map. The reason is we want to reuse the map inside here. So every time our timestamp updates, we want to mutate the data, the DeckGL map, the DeckGL layer. We want to mutate the layer and give it new data. What new data? Well, we want to update the time. We want to say, okay, so here's my layer, and every time it changes, every time my time changes, I want the layer to update with a new timestamp. So we're not going to use DeckGL layer. Instead, we're going to decompose things. We're going to put in a trip container here, which is just an HTML div. We created one of these inside our getGL map call. We're going to do it inside we're just going to create a trip container here instead, separately. And then we're going to create a trip DeckGL over here, right? So this is going to populate trip container with some data, with the same stuff we put in before, and give it 0 layers. We're going to put the layers in elsewhere. So I'm going to show you what that looks like. So now we got this trip DeckGL, we got the scrubber, and we got the map. All right. So now we're going to create a onChange function, well, cell. So over here, we're going to create a layer using trucks, right? We're going to give it get the path we normally get. We're going to use the timestamps. So inside trips layer, we have it get timestamps, which was different, right? And the paths we didn't, because paths are just all they are timeless. They don't have any time variable. We're going to get the color, put in some opacity, so make it a little bit easier to see through them. Put in a trail length. The trail length is how long you want the trail to be. And then a current time, right? So the current time here is the current time we have in our scrubber. It's our view of, right? There's a view of current minute. You can see current minute. I times it by 60, times it by 1,000 to get the milliseconds since epoch. And then I set props. So this is different. So I'm setting the props separately in this onChange call. I return onChange here, but I don't have to return anything. I just return onChange as a string, so that to help understand what's going on. But basically, this cell runs if any parameter inside the cell changes. Current minute changes. Every time this, you can already see. All right. So every time this view, this current minute changes, it's going to run this cell, which replaces the trips layer inside the DeckGL object. And it's the same trips layer each time, but the only thing that gets updated is the current time. So this, and you can see here, I'm going to bring it up. So we're going to play here. You can see here every time over here this is gray, and it's kind of blinking. This onChange. That's because the onChange cell is running every time our scrubber changes. When the onChange cell runs, then the map updates, and that is how we get the paths to work like this. So I'm just going to move this down here. So that's kind of cool, right? So now we got the paths, and we can go back and forth, right, inside here and see what individual trucks are doing at the specific time of day on February 15th. And then, so they stop moving around, right, when there's no snow. And then we had another day when there was more snow, and so they come out, and you can go and watch the trucks, right? You can speed up the trucks by making this update, like every 50 instead. So now the trucks are even faster. But there you go. And so that's our final map. Okay, good question. So Brett has a question. Some of the paths don't seem to follow roads. Why is that? So it's interpolating. So basically, the truck at some point was followed by GPS, and then it showed up somewhere else. So maybe the driver turned off the GPS. I don't know what these components look like, or maybe the GPS, like the cell tower, like it ran out of signal strength or something like that. And so the truck sort of appears somewhere else, and then it tries to interpolate where the truck's path by just a straight line. So that's why you're seeing stuff. There's the occasional data anomaly here. Particularly, you can see here from where they park, right? Like this show up somewhere. Like I assume that's because they turn the GPS on here. Right? They just show up somewhere, and it's like the paths things sort of says, okay, so I assume it just took a straight path through it. But there you go. That's why there's the occasional straight line in here that makes no sense because there's no roads. Data anomalies. Cool, not flying trucks. Yeah, absolutely. Yeah, not very useful flying snowplows. but I don't know. Anyway, that's the. Any other questions? Cool. All right.
I had a quick question. So I was just wondering, because in your examples, you're mainly using like one layer. If you have multiple layers, are they just superimposed, or is it just one layer at a time? You just pick a button that switches between the layers?
Yeah. Good question. So like, let's see if we can do it. So let's take this path, and it's better if I just show you. And let's put it on top of the heat map. So it's just, as you can see, our layer was an array. And so we'll just put the heat map layer, we'll put the path layer on top of the heat map layer. Let's see what happens. So there you go. So there's the heat map with paths on top of it, which kind of looks weird. But yeah, so it is just superimposed. I think there is, so if you, I think it is based on the order you put them inside the array. So with that one, I don't know where the order of precedence is, but the last one takes precedence, or the first one takes precedence. It looks like the last one takes precedence. Yeah, we can actually check that out. Because what'll end up happening is some data replaces the other one. Yeah, you can see now what we did is we made the heat map take precedence, and so that'll be on top. So depending on the order you put them in the visualization, that's the precedence it takes. But it's just, yeah, it just throws them on top of each other. If they had opacity, then you could see from one layer into another layer as well. That's an option. Good question. Yeah, multiple layers.
I had another question. It was thanks for the demo. It was really cool learning about DeckGL. Is it would you, I don't know, recommend it, or like when would you use DeckGL over, I don't know, possibly other libraries?
Yeah. So I use it all the time now because it's so easy. I prefer it over the competitors like Mapbox.gl and Leaflet, and and all that. It's because this is so like the later examples we gave looked a little bit complicated, but those are just because they're complex visualizations. The simple visualizations we did at the beginning were like, just really easy to knock out. And so I use DeckGL across the spectrum. So if it needs to be, if I need power, I know it has it. There's a lot of flexibility in the API. And if I don't need power, it's still easy to use. And you don't really see those things at the same time. I'm pretty impressed with the library. Yeah, I use it for both sort of use cases. I prefer it over the competitors, Leaflet, and Mapbox.gl, and the Google Maps API, and all that stuff. Yeah. One thing it doesn't have that you got to watch out for is if you want to like understand directions between places. This is just the visualization layer. So Mapbox has like a bunch of calls, and Google Maps has a bunch of calls to say, okay, so get me from point A to point B. What's the directions? What are the directions to get there? If you wanted to map the directions, you would just use DeckGL to show the results. But there's other API, but there's no API to do like drive times and that kind of thing. So I guess to the real answer is if you don't need any of that, if you don't need a drive time, you just need a visualization layer. DeckGL is really easy. There you go.
Cool.
Any other questions? We've got lots of time, so I'm happy to answer any. Cool. All right. So the other stuff. So like, what else have we built with Deck? So other stuff were built with DeckGL. So just to give you some inspiration. So here's the Nunavut ring seal hunt when it loads. That box is being grumpy. So here's the Nunavut ring seal hunt by year, right? Same kind of thing with the scrubber, but it tells you the number of seals and the average length of the seal and the average weight of the seal in the specific part of Nunavut. So that's kind of fun. Here is Christmas trees in Winnipeg. So this is using hexagons. So this is a good example, right? So the heat maps was pretty good because there were roads. But if you did heat maps for Christmas trees, maybe it's okay. But hexagons, I think, are a better use here. So here's a hexagon map of all the trees. Winnipeg has a tree inventory in their open data sets. And then I color it on a different dimension, which is nice. So more trees, higher hexagon. More green means more Christmas trees. So that's a proportion of trees in the hex that are Christmas trees. So there you go. Walk times to municipal services in Windsor, Ontario. So I created a dot. So here's a scatter plot. I put a dot at every intersection and then measured the sum of walk time to nearest school, library, bus stop, park, and community center. So that's what that looks like. BC property tax rates. So here's the scatter plot for the property tax rate in British Columbia. And there's one more. What's you might consider doing too is combining two visualizations together. So over here I have a population pyramid, or basically like a histogram with out-migration and in-migration of people to and from Windsor, right? So here's Toronto, right? So we lost a bunch of people to Toronto in 2016, 2017, but we also gained a bunch of people. We gained more than we lost. That's shown in the map. And so here's the map. Oh, it's got a little bit wonky. The layers are all mixed up. Probably have to refresh that. What's cool is you can click on other CMAs inside the come on. Watch, it's not going to work for me now. There it is. You can click on other CMAs inside the map, and then it adjusts the population pyramid and the visualization on top of here. So that's kind of a fun thing you can do inside. Again, this is all inside Observable, so you can combine two kinds of visualization inside inside one sort of notebook and see how things work. Anyway, so that's some other things you could try. DeckGL has a bunch of examples, very cool things that aren't Windsor related. my stuff's very Windsor flavored. But yeah, no, if you want to, they like some stuff on moons, right? So you can replace your own tile layer and then do visualizations of the moon with a new tile layer. Over here, this is actually a point cloud, so it has nothing to do with mapping. It's actually mapping the 3D, the 3D representation of a house. Pretty amazing library. Like I said, extremely flexible if you need it, very easy to use if you're just looking for something simple. Good. Can use D3 to draw on the map. So we did a little bit. So we used D3 in our example to do the color scales. Can you use a D3 visualization on the map itself? So maybe you're doing a D3 what would be an actual? I think the answer is theoretically yes. I think the DeckGL has enough flexibility to let you do that. And it's interesting. So if you have an idea, then that'd be pretty cool. But I don't exactly see the use case. But maybe you're more creative than me. Go give it a shot. You will have to do a lot more like detailed, dig into the depths of like maybe building an extension or other things with DeckGL. To make that happen, but it's might be possible. Any other questions? And we'll wrap it up after that.
I had a question about the Observable website.
Yeah.
What are like the use case where you would recommend to someone? Yeah, you should check this site out. This could fit your needs.
Yeah, I basically if you're there's a lot. So there's a huge community of people building notebooks on Observable. Like so a lot of these are D3 related, but the a huge community of people building things, and so the I'd recommend anyone who's wants to show data in some way. So notebooks are best for that. So and then being able to share it in a way that allows people to see the code and the data, which is important. Lots of people don't do that. It's like, how did you get from point A to point B? What you want to see the individual steps. All the code is exposed in Observable. And so, yeah, I would recommend that. Also, if they're having a lot of fun, if they want to use, if they getting started and they learn best by looking at examples. There's tons of examples in the sort of in Observable, and you don't have to use any of these fancy libraries. Like I did one. It's just anything JavaScript based. So like I did here, the U.S. electoral college results from 1900 to 2020. All this does is gets the SVG files from Wikipedia, and then scrolls through them with a scrubber, and uses jQuery. So uses jQuery to update the map instead of some other fancy thing. So this is basically just like paging through pictures, except you get a little scrubber, which is kind of fun.
Cool. So can you make it private, or is it just anybody's able to see it?
Yeah. So if you publish, so everything's private when you begin. So if you click notebook, and so we created this like if you create a new one here, no one can see it. So hello, right? It's private until you publish. If you click publish, then anyone can see it. They've also got this new thing here, which if you switch to next, which is like the next version of Observable, right? So it's like stuff that's in beta. You can share instead, and over in share, you can send it to another Observable user to edit or view, or you can just I think you can enable link sharing, right? And so now this is private for anybody who has private to anybody who has the link. And so if you like do something for family and you just want to send a link, unless you know the link, you can't get to it. But if they share the link with someone else, they'd be able to see it. So if you could do private by doing the share, or you could do make linkable to get sort of unlisted, like an unlisted YouTube is kind of the equivalent, and publish is just public. So the answer is yes, but you might have to get all the features, you might have to switch to next.
Cool. One last quick question. What can you export it as? Because it seems kind of proprietary. Like,
Yeah.
So
that's a good question. So like, there are so like there's a you can download the code and then and also embed it from one site to another. So here's the code, which is like you get a TGZ file, but I think it's
the code's not necessarily gonna work, right? Depending on if you're using observable specific code.
Yes, exactly right.
Yeah.
So you get the runtime, the observable runtime inside this JavaScript file too. And so it is exportable. Yeah. So like you are tied a little bit. The good news is you're not tied a lot. This is fairly easy to move to a different platform. Um, uh, but yes, some of it is observable specific. If observable goes away, I would have a hard time taking 78 notebooks and trying to figure out a good way to sort of preserve them. I probably use my own website and that kind of thing. So I have a personal website, so you could put the stuff up there instead. Yeah, so I probably end up doing that, but it would take a lot of time and effort to sort of migrate it there. So yeah, I think there's been a lot of demand and requests for self-hosted versions. It'd be nice to self-host. For instance, I work in information security. There's no way I could put up, and I love observable notebooks, but there's no way I could put anything I work with on observable because of issues with confidentiality. But if I had a self-hosted versions, then maybe I could work that out. Unfortunately, they don't. I haven't concentrated on it. They wanted to do more of the community angle instead. But there you go.
Cool. Thanks.
Yeah, no problem. Good. All right. Any other? Well, I actually I'll let everyone go now. Thanks very much for attending and working through this with me. Like I said, I'm about to publish the make public the original tutorial. I just have to do a couple couple items of editing. And so if you go to observablehq.com/@John you will be able to see the tutorial, which includes all the steps. But don't go there today. Go there tomorrow because I won't have it. Ready until then. But I put the link to my observable page on in the chat. Good. Thanks very much, everyone.